Welcome again to electromagnetism, electrostatic fields. Again, we are with applications to Coulomb's law, basically the electric field due to a surface charge. We have a unit surface and we have an observation point and some vector between them. Remind ourselves we have E equal to Q 4 by epsilon naught R squared in the direction R hat unit vector. Simply, due to this charge density, we cannot use this law directly. So we start with a small portion dq. This means that this one is dE in over surface, and then we replace dq by its equivalent, which is rho s ds. Then to get the overall field, we just do the double integral here, this time over the surface. And finally, you will get this equation that E is equal to double integral rho s ds over 4 by epsilon naught magnitude r square r hat direction. We have one example. Let's read together. Determine the electric field E due to an infinite surface. This one is an infinite surface placed in the xy plane and has a charge density which is constant, means is uniform, rho s Coulomb per meter square. And let's do the solution. And again, this time we will not do over the surface directly. We will use the result which we got from the previous video, which was that due to a line placed somewhere. Last time it was in it was in Z, but this time we just using xy plane. Basically, we assume it is in a line parallel to the x-axis, and we are observing not to rho. We will say name it just r. dE will be just rho s dy, because now x is already done. I mean, normally we should have used dx dy, but since the line is parallel to x, we already done this problem in the previous video. So now we only left with dy, so rho s dy representing the charge, and r is the same as before. So let's do r calculation, and I assumed here that the point of calculation is placed in the z-axis 0 and 0 and z, and our point of observation is placed in the y-axis, which is 0 y dash and 0. And why this is a valid assumption? Because if we have another line placed here, for example, at the same distance, so this y dash, this means this one is placed at minus y dash. Again, from the previous explanation, if you have the field this way, let's use another color. If you have the field in this way and you have another field this way, these two will cancel in the opposite direction if we have the component analyzed, and the component in the z will accumulate. So from the previous slide, we understood that j direction component will vanish and we are only left with the k direction. That's why the portion of I relevant to j I removed from the calculation, and then I just substitute with the required values and reformulate. Then we need to calculate this value, and simply we need to calculate the integral to get this was dE. Now we are with E, and here we have one integral because we are using the result due to the line, and the result due to a line already consider the dx component, so we are only caring about the dy component. Finally, if you make mathematical manipulation, you need to calculate this integral, and to calculate this integral, this actually looks like the integral relevant to 1 over 1 plus alpha square, and this one, if you integrate it, the alpha, you will get tan alpha. The only difference here, you have this z here, not 1. So if you rewrite this one, z over z square y dash over z square plus 1. This is solvable the same as this one, but you need to take care about that. And finally, ultimately, if you solve this one, you can find that it is just equal to 10 minus 1 y dash over z, and the term remaining here was cancelled due to the calculation. And finally, if you solve it, this one, I mean substitute with from minus infinity to infinity, you will get by, and substitute in your equation here, you will get that your e is just equal to this value, and by cancel with pi, and this is the final equation which you need to remember for later. Thank you.